Imagine you're a project manager with limited resources. You need to allocate time and budget wisely across multiple projects, all with different demands. How do you decide the best allocation of resources? Systems of linear equations provide a systematic way to solve such complex interconnected problems. Today we'll dive into the basics of systems of linear equations, a fundamental tool for solving problems with multiple variables and constraints. In this video, we'll explore the foundation of systems of linear equations, starting with the definition, types of solutions, and why they matter. We'll also look at how these equations model real-world scenarios, providing a base for practical applications. A system of linear equations is essentially a set of two or more linear equations with the same variables. For instance, let's take the equations. 3x plus 4y equals sine 10. Has turn 5x, 2y equals sine 8. In these equations, x and y are the variables, and the system is a group of equations that we aim to solve simultaneously. The goal is to find values of x and y that make both equations true at the same time. Consistent and independent. This happens when there is exactly one solution, meaning the lines intersect at a single point. For example, if we solve the equations 2x plus y equals sine 5 and x, y equals sine 1, we may find only one point, like 2, 1, that satisfies both. Consistent and dependent. In this case, there are infinitely many solutions, usually when the lines coincide or overlap. For example, equations like 2x plus 4y equals sine 8 and x plus 2y equals sine 4 are multiples of each other. Any point on one line also lies on the other. Inconsistent. When no solutions exist, this is because the lines are parallel and never intersect. An example could be x plus y equals sine 3 and x plus y equals sine 5. Since these lines are parallel, they'll never meet, and there's no solution. Let's consider why these types of solutions matter. In project management, the unique solution scenario is like having a single ideal plan. Multiple solutions might represent different but equally feasible plans, and no solution means there's a conflict that needs reevaluation. By categorizing solutions, systems of linear equations help in understanding constraints and finding the most viable path forward. Methods of solving systems. To solve these systems, we can use different techniques, each with its advantages depending on the context. Graphical method. Here we plot each equation on a graph. The point where the lines intersect is the solution. For example, with equations x plus y equals sine 4 and xy equals sine 2, we can graph these lines and visually find their intersection point, which might be 3, 1. Substitution method. In substitution, we solve one equation for one variable and substitute this value into the other equation. It's particularly useful when one equation is simple, like y equals sine 2x plus 3. Elimination method. This method involves adding or subtracting equations to eliminate one variable, simplifying the system into a single variable equation. We'll explore this more in the next videos. These methods allow for flexibility in approaching various scenarios, whether visually through substitution or by simplifying through elimination. Now, here's a quick challenge. Consider the equations x plus 2, y equals sine 6, and 3x by y equals sine 5. Which solution technique, graphical, substitution, or elimination, do you think would be easiest to use here? Think about your answer, and then we'll discuss it in the following videos. Real-life example or case study. Let's take a real-life example. Suppose a small business produces two types of products, A and B, that require labor hours and materials. Product A takes 3 hours of labor and 2 units of material, while product B requires 2 hours of labor and 4 units of material. With only 12 hours of labor and 10 units of material available, the business needs a balance to maximize output. The system of equations for this would look like 3x plus 2, y sec 12 labor constraint. Here 2x plus 4, y 0 10 material constraint. Solving the system shows feasible production quantities for both products within available resources. Think about a situation where you have limited time or resources and need to make optimal use of them. How could using a system of linear equations help you identify the best possible solution? Thank you for your time. Stay tuned for more videos to come. We welcome your feedback on your video viewing experience.